Scale 13. You guys are high energy and smart, and I've got to say this has been one of the most educational conferences I've been to in a long time, because folks tweeted from track to track, and I did my best too. So being in one track, I got to get some nuggets of wisdom from all the other tracks. That was awesome. Thanks, guys. And two, the people in every track were fairly advanced Agile users. Now, they were open to questions like, well, do I need a Scrum Master on each team? And questions that teams have early on in their life. But they were open to very advanced questions, and there was a lot of that. This has been fantastic for me. Thanks for being a great group and asking great questions and having great content and being smart. I'm Joe Justice. I'm the team lead of Team Wikispeed. We'll talk about what that means in a minute. And I'm a business process consultant from Seattle, Washington, United States. So if this were a map of the United States, Seattle, Washington would be right up by the M in the top left of the country. And I have technical difficulty.
Microphone public? That's an opportunity.
What happens when a business process coach starts and runs a automotive manufacturing company? Yeah, in a way. In that case, what would happen when an automated loom company moves into automotive? And when it's automated looms, they need to make sure that when one device fails, it doesn't continue making bad parts because there's only so much money. And they can't have an automated loom running all night producing defects. And so they developed the idea of the and-on light to say, not only have I failed, but I'm going to stop so I'm not producing flawed parts, which was a phenomenal cost-saving measure, right? Well, what happens when it's a Scrum Master and then later a Scrum Coach? Well, let's take a look. Team Wikispeed is a registered automotive manufacturer. We legally sell cars. They're ultra efficient and modular, and I'll show you a little bit about what that means. And we use Agile, Lean, Kanban, extreme programming, and extreme manufacturing, and we use Scrum teams and radical management in our board of advisors. These are all buzzwords, and they all add a lot of value. This is one of our cars now. In the United States, in simulation of the city and highway test, it posts 104 city and 114 highway. Approximate conversions in the UK, that's 158 miles per gallon, approximately. And on the German test cycle, that's about 2.5 liters per 100 kilometers, which does pretty well. And it's quick. It's 0 to 100 kilometers per hour is 5 seconds, which for an economy car, a fuel-efficient car, well, it's really fast. And I think it looks good, too, but that's a matter of opinion. But really, we do all sorts of social good projects, but the ultra-efficient modular car is the best known. I think because it's easy to take a picture of a car. It's a little bit more difficult to take a picture of Scrum used to enhance the way the polio vaccine is distributed in congested neighborhoods in urban India. In 2008, the Progressive Insurance Automotive X Prize was announced their letter of intent program, where you could start to say, I'd like to enter the Automotive X Prize. They put a $10 million US prize purse on the table to see, is anyone able to build an ultra-efficient car that seats 4 adults and meets all road legal safety requirements. And by ultra-efficient, they used the United States cycle. They put 100 miles per gallon city highway. Now that's about double the current Toyota Prius. And this was in 2008, so it was more than double at that time. In 3 months, we had a prototype on the road. That's uncommon. And we had a team of 44 team members in 4 different countries. 16 of us flew to Michigan International Raceway to campaign that version of the car. Then, about 6 months later, we made this more aesthetic version. Our goal is to have cars that people would want to drive to work every day, so that we've reduced urban emissions in congested city areas. And that's not going to make a significant impact for the environment if only 10 people are driving our cars. So we needed to make something that a lot of people would consider driving. So we knew we had to prioritize aesthetics. Then we received this rendering and said, that's beautiful, we should build it. And that was from a person that previously I'd never met in reality. It came from the internet. Rob Morbacher was his name. He sent us the CAD file through Windows SkyDrive. And we said, Rob, we'd like to build this car, it's gorgeous. And so we did. And this picture is from Agile 2012 in Grapevine, Texas. And I was invited to do the closing keynote of that conference. And we unveiled for the first time in carbon fiber the WikiSpeed Roadster, which we sell now. That car was built backstage in 2.5 hours by conference attendees who'd never seen the car before. We sent out an email saying, a new session, who would like hands-on experience with Agile for hardware? And 23 people showed up, not knowing what was going to happen. And we didn't show them a picture of the car, and we didn't show them any instructions, we didn't hand them a 3-ring binder. We put a bin on the floor with a first aid kit and a fire extinguisher in it, and we said, this is your safety orientation. All of the safety gear we could find is right here. If you need something, go right here. And then we put another bin next to it with all of the tools we could find. So we had wrenches and brake line flare tools and files and saws and drills and epoxy. Everything we could find was in another, actually it ended up being a set of bins. And we said, here's all the tools we know about. And then we took another bin and we put the healthiest snacks we could find from the conference catering in there and water, and said, here's the snack bin. If you need a snack or you need some water, don't wait to ask, grab it here. So they had safety stuff, everything we could find, they had all the tools we could find, they had all the snacks we could find, and then we made a backlog of not bolt this to this, but of tests. Things like, as a conference attendee, I can push the WikiSpeed car and it rolls straight. Right? So they'd have to hold the wheels somehow in place, right? And we iterated the car through pairing. So this is Clayton Osterman in the blue shirt here. He's the scrum master of one of our shops in Seattle, Washington. And he's pairing with our intern from Turkey, Emre Aras. And they're putting together suspension modules. So these two people, we'd never met before, they were conference attendees, and they were started as a pair, and now they've become a swarm, assembling suspensions. This is Tom Tabor in the white shirt here. He leads our Las Vegas, United States shop, and he's working with people putting decals on the carbon fiber car body. And that started as a pair, and now it's become a swarm. And then this is the pair I was in, and now it's a swarm, and they're building the chassis. So they're drilling out sections of the chassis here to make clearance for the suspension modules to attach. All those people now know how to build their own WikiSpeed car, and we published this version of the car for free and open source online. So they can build their own car, they never have to talk to us again. We sell cars, and the day we announced the car was available for free and open source online, we sold another car and got a deluge of additional investment. I don't claim to understand how the open source model benefits the traditional capital model, but I will say in our personal experience, it's working great. And I periodically see forum posts from someone saying, yeah, my WikiSpeed car does this, and I've never met or heard of them. So apparently there's people building their own. I haven't met them, I just see forum evidence from time to time. Then Lockheed Martin called us and said, you guys build cars really, really fast, and they meet road legal safety specs. And we said, well thanks, yeah, that's exactly what we try to do, and we've had some success. And they said, how about you train about 250 of our employees in Agile for hardware, because we've had so much success in Agile in our IT departments. We want to scale that out to missile systems and below ocean missile launch systems And some other projects, and we said, okay, well, let's reduce waste. Let's try to make that happen. So we said we have 2 days with these people. How are we going to give all of them hands-on experience with Agile for hardware? Well, this is what we tried. Rob Beresford, who at that time was the product owner of our Seattle, Washington shop. There's shops in 20 countries now. And this is Rob and Clay, who you'll see are from one of the shops. And Rob's holding our entire chassis. It's the lightest chassis in the world to receive a 5-star crash rating equivalency. It's 124 pounds, and it's this extruded aluminum box. So he was able to walk in carrying it himself. That was the frame of the car. And then we gave them a roll of carbon fiber. For those of you who have not worked with carbon fiber before, when you first get it, it's in a roll often, and it's like black silk. You can bend it and move it how you want. And then you mix up epoxy, like glue, and you pour it on there, and it becomes one of the hardest, strongest, and lightest materials humans know about. But it starts like cloth, so we gave them a roll of this. And then we had it catered, very important. Yeah, that was the snack shelf, right? So we were able to upgrade that. And then all of our tools were put out on, we had folding tables this time instead of bins on the floor. And you can see there's numbers here. We're still figuring all this out, right? But in our current opinion, we think there's 5 things you need to do to build physical things with a Scrum team. And this is number 4, have all the tools visibly in one place. If they're in drawers that you can't see the contents, people don't know where to find the tool. They don't know what you have and what you don't have. It doesn't work well with a team. It works well with an individual, but not well with a team. So that's practice 4. Practice 3 is have a snack shelf. Practice 1 is the safety shelf. And then practice 5 is, again, we didn't give them a training manual. We didn't show them a picture of the car. We gave them a backlog of tests. So these were things like, as a Lockheed Martin employee, I can jump up and down on the chassis, and it absorbs my inputs. Now, they had suspension modules there, but they had to figure out what to do with them, how to iterate them, how to change them to pass these tests. And you can see this picture was taken near the end of the workshop because most cards are on the left, are on the right side in done. And they're organized by sprint, so we could track what was done, what sprint. And you can see there's this push at the end. Interesting. There's a reason for that. We had a blocking issue. A lot of these have to do with final assembly, and we had to wheel the car out to where its time lapse would finish. Then there's stuff at the bottom here. Well, these pink cards are Moscow cards. M, we must do this. Those have all gotten done. S, Moscow, we should do these. All those have been gotten done, one still in progress when this picture was taken. Must, should, could. We could do this. Most of those have gotten done. And W, won't. We've decided we won't do this, but we want to make it visible and explicit that we thought about it. It was a good idea, but for whatever reasons, we've decided not to. So you can see this is right near the end. And they got to here, and they had the suspensions partly on, and they'd started to make a mold to lay up a carbon fiber interior bucket that you put the seats and seat belts in. And then they got to here, and it was really starting to look like a car. And then they got to here, and we celebrated. That was kind of awesome. And then they had to take it all back apart again because they built it in a conference center. Then Red River College in Winnipeg, Canada said, we want to make this, and by then we'd given it a name. We called it Extreme Manufacturing, to say thanks to Kent Beck and the amazing work he's done with extreme programming and the whole XP community. And so we named whatever this was that we were doing, Agile for hardware, Agile manufacturing. We started calling it Extreme Manufacturing. Red River College said, we want to teach extreme manufacturing as part of our curriculum. We said, yes, please. We want to stop having to retrain people when they reach us. We want them to already know this so we can just get about making the world a better place. And they said, let's do something similar to what you did in Lockheed Martin. they built the car in 1 day. In day 1, they built it in 1 day. So in day 2, it started with them taking it apart and then building it again. And so they got to be hands-on with contract first development, or defining the contract they're going to build before they build it, and then in loose coupled modularity, making sure the thing could be changed in pieces and not affect the other pieces, the loose coupling. And for that, they learned a little bit about test-driven development, or how to make sure these modules are going to be safe to use. And I'll talk about that a little more in a minute. How do you make this regulatory compliant when you're sprinting like this? And then they got to work as a Scrum team. Well, the whole time it was a Scrum team, but then they got to be doing the physical build. And in day 2, they took it apart and put it back together, and then took it apart again in a day. And that's what we have the time lapse from. This is all only possible because the car is modular. If there's one takeaway from this keynote today, I'd say it's this. And in fact, please consider taking a picture and tweeting this. I'd be grateful if you did, because I think this is what's going to make the world a better place. Here's what I mean. Do what? Go back a shot? Well, I think it's kind of funny to have it explicitly say, take a picture. Joe asked me if I'd do him a favor and take a picture. The car splits into 8 pieces, and each one is loosely coupled from the rest. So this is the pedal plate, for example. It has the brake system, the accelerator pedal, and the steering rack on it. So that means if we were going to make the car autonomous, self-driving, this is the only part that would need to change for a dramatic change in functionality like that. Or if we were making any other changes in UI, user interface, this is the one part that would change, for example. Or the engine is a module in the back. It's mid-engine rear-wheel drive. It's actually the most efficient layout. It's also fun to drive, but we chose it for efficiency reasons. We're able to switch that from a gas engine, gasoline, petrol, to diesel or methanol or alcohol or electric in about the time it takes to change a tire. Because step 1 was developing how these parts are going to connect to each other without knowing what they are. So we didn't solve the problems up front because we didn't know how to solve them. But we divided the situation into loosely coupled modules. Here's why this is so important. If in front of us here today we had a Toyota Camry or a Ford pickup truck, and as a team, as a group, we were asked to change the steering rack, the part that when we turn the wheel, it actually pulls the tires of the car one side or another. Say we were asked to change that. Well, we might fabricate that up. In the corner, we might have some machines and tools, and we might make a new steering rack, right? Well, chances are that would change the steering column, which would change the steering wheel, which would change the airbag, which would change the angle and speed at which it needs to deploy to be safe. Well, that would affect the wiring diagram of the car for the airbag sensor strategy, and then the programming of the car that sits inside the airbag control module. That would all require stamping a new floor for the car, which is a $10 million tool change. If we were an average automotive company, that would take us 3 years. Because of all the systems that it's tightly integrated with. The opposite of modularity I'll propose is integration. Well, integration has value. You're able to optimize within the integrated area. But if we have modules and then optimize or integrate in the modules, but they still connect the same way, then we can move very quickly. So in Team Wikispeed, that same thing, the steering rack, we can change it every 7 days. Object-oriented architecture allows us design patterns, so we can say, hey, we've seen this problem before, we solved it with this type of suspension module, let's just do that again. And we bolt the same one on. So different just than design inheritance, this is actual full usable module inheritance. It also allows reuse and inheritance across the project. And from these we start to see speed gains all throughout. I would appreciate if you would consider taking a picture of this slide. You don't have to, but I'd be grateful. You guys are great. Thanks for humoring me. I think it's important. We'll see if anyone retweets and if they think it's important too. Thanks. Okay. Much obliged. So again, we gave it a name. We had enough hubris, enough false pride to say, yes, let's name this thing. I'm still not sure if that's actually appropriate, but we did. And basically all it is what everyone in this room has been talking about for the last 2 days. Scrum teams with XP practices, and then we're being explicit about object orientation, even though almost everyone in software uses this by default. This is not common outside software. So this part, I actually took this for granted. And then when I did a class with Jeff Sutherland, which was awesome, he's amazing, he said, Joe, you need to talk about this a lot more, because none of the clients in the room, because none of them were from software, know about object orientation. He said, that's a first-class citizen. You've got to talk about it. So it's Scrum plus XP plus OO, which everyone in here, if you have a software background, is already familiar with all of these. And that's it. That's the whole recipe. And we think that's, for design and manufacturing, the coolest thing we could be doing. Then John Deere gave us a call and said, the population of the world, if it stays on its current trajectory, will run out of food by 2025. We will need to change the way we produce food. I don't know if that's true, but I did get to see the presentations pitching that. Well, and holy wow, if that is true, then we really need to change the way we produce food, or take some measure. So John Deere says, we need to dramatically change the way we do crop production. Let's launch WikiDeer inside John Deere. And we came and started doing work with them. And unfortunately, I'm not allowed to say on what projects, but I can say that we're working with John Deere and doing WikiSpeed projects inside. And then Boeing, one of the largest manufacturers of aircraft, commercial and military in the world, came to us and said, let's work together to solve problems much faster. Let's be more like WikiSpeed. And we started working with them. And then TCAN in Manador, Switzerland, they make automated and semi-automated laboratory testing equipment. They said, let's relaunch ourselves as an agile company in our hardware and hardware design. It's already looking good in software. What does it look like in the rest of the company, including our management, our finance department, and our legal department? And we said, yes, let's do that. And by the time we'd worked with them, we'd gotten our basic pitch down. We had a set of practices for launching teams. Here's how you would be like WikiSpeed. If that's what you wanted. Here's what we think is the right thing to do. Here's what we're learning. And the basics, Agile, Lean, Kanban, Scrum, extreme programming, extreme manufacturing, and radical management, we got down to a 1-hour session. And we'd cover those, and then we'd get on to launching the team and actually doing work. So the academic part was compressed. By the time we'd done it with these companies, that's about as quickly as we were able to go. And this was completely awesome. This picture is from Rome, Italy, where we had just done with 20 companies at a time what's been called an Agile 2.0 change. There's so many buzzwords. A way of thinking about it is if you Google or Bing or Yahoo search Agile, most of the examples you're going to see are software delivery teams. If you buy a book on Agile, most of the examples you're going to see are software delivery teams. In 2004, that's the first time I saw it written, someone said, well, we've been applying Agile and Scrum and XP and lean thinking beyond our software delivery teams. We've been trying it in management, we've been trying it in our finance department, we've been trying it in hardware. We're an Agile 2.0 company. We're trying Agile in the whole company. And that word's been bandied about since 2004. Well, then in 2008, a guy named Blake Lindsay said, well, what about Agile 3.0? Some of these teams go 10 times as fast as they used to go if they measure velocity before at all. Some teams hit 10x. Is there any commonality across these teams? Is it repeatable? Is it knowable in advance? Can any team do it? And the collected evidence of those ultra high-performing teams said, yes, any team could do it. They do have a commonality, and what we think it is morale as a multiplier for velocity. They're able to take Maslow's hierarchy of needs and see how the work they're doing builds on their sense of mastery and their sense of purpose and self-actualization. So when we do what we call now, what WikiSpeed calls now, an Agile 2.0 launch, it means we're doing Agile in the whole company. And then when we're doing morale practices, if that's appropriate for what the company's doing, we call it an Agile 3.0 launch. Here's an example that I get to talk end-to-end about. Tate Communications has given WikiSpeed permission to post every part of the work we did with them, so we're very lucky. They make these hardware devices, they're radio systems. So this is one of their base stations. This is the P25 radio base station. It sits in a rack like a server. And here's their handheld unit and their mobile unit and another mobile unit. They flew myself and Tim Meyer, another Team WikiSpeed member, in. You can see Tim's nose right here, poking out from behind the Scrum board or the Kanban board. And we said, well, we've got 1 week with you guys. And they said, yes, teach us about how you guys run a team. And we said, okay, well, we'll try. But what's the current product you're building? And they said, it's that P25 base station. We're making the next version. And we said, okay, what's the fastest you've ever built it before, a new version of it? And they said, well, one version we built in 3 months. I said, okay, how long does it usually take? And they said, about 1.5 years. And we said, okay, well, let's try to make one in a week. That was exciting, and management came in and watched every day because they were saying, well, even if this gets even 1/10 of the way close, it'll be a record. And we said, if we're going to try this, we're going to need everybody in one room that's involved in making the next version of this base station. So they gave us 3 types of hardware engineers. And in one room, they brought testing equipment for circuit boards and soldering equipment and soldering hoods, the stuff that connects circuit boards together, that type of thing. Inspection equipment. And we had them put every step they know of to make the next version of the radio on a backlog. So that's how they started. That was day 1. Everybody get in one room and write sticky notes until you think you've written everything you need to do for this to be shippable to a customer. So not just done academically, but we could actually start putting it in customers' hands. And we realized before day 1 was done that there's software that runs in the base station, embedded software. And then there's software that runs on a desktop to manage the base station. But we didn't have any software resources in team. So the product owner put the sticky note that said, we're blocked, we need this, on his shirt. Because we'd already asked for those people and been told, no, that's just too expensive. So he put that on his shirt and he walked around. And within an hour, the note saying, we're blocked, we cannot progress, we need this. And he was blocked. The COO walked by in the hallway and said, you're blocked, your whole team stopped? He's like, yeah, there's 30 of us in that room and we've got nothing. So it was solved 10 minutes after that. We had the software resources. Then we realized who else we needed. We needed sales because they knew the most about what the customer actually wanted. And we needed packaging to put this in boxes and wrapped with manuals so it could be shipped. And we needed more types of QA than we had. And some of the people from the PMO office came as well. And then they were all in one room for the rest of the week. But that was just the design piece. They said, well, say we can design this thing in 1 week. How do we get it to the customer? So then we went to the manufacturing side of the company and said, how long does it take you to retool for a new design? And they're like, well, we build a new factory. It doesn't happen every day. And they were already doing stand-ups as a lean manufacturing organization, and they already had visualizations of flow. They were actually a Toyota process system, a TPS, which is actually thinking people's system, according to people in Toyota. But they're already a TPS company. So they had a lot of practices that were familiar to me coming from a Scrum background. And we said, well, let's try you guys being a Scrum team, and you start the day with a stand-up saying, here's what we're going to build, how are we going to do it? And so they might have to wheel around pieces of machinery, they might have to procure new parts, what's the lead time on that? Are there vendors that you could work with that have a shorter turnaround time? They ended up ordering, last I heard, a circuit board printer, so they could print their own circuit board in the Scrum room, and then making that part of the flow-based manufacturing line. So step 1 is, how do we design much faster than we've ever designed? Because by the way, that 3-month figure was just for design. And they said, well then, how do we produce it? Because we said it's not done until it's in the customer's hands and it works. And they're like, whoa, okay. And for that, they needed test-driven development. And so this guy stands next to the manufacturing line, and he makes test fixtures out of cardboard and foil tape. They hold the circuit board in place, and they do a logic test by putting probes on it. There's either a red light or a green light to say this board passes logic or fails. Well, since the circuit board could change any day, the fixture that holds it needs to change. So he stands next to the line, makes a holder, walks over to the line, they see if it works, they say, can you change this? He says, okay, and he makes another one, he walks back. They can see each other. They're 20 steps from each other the whole day. And then when they say, yeah, we like it, he uses this machine behind him. It's called a bridge port. It's called a lot of things, but that's one of its names. And he makes it out of aluminum. And then that lasts through thousands of parts. But it's not expensive either, they can still change that. And so now they had agility in manufacturing. The third piece is it had to be object-oriented. And I didn't find a picture of how they ended up splitting up the circuit board. But you know when ZIF sockets came around, or the idea to pull the chip out of your motherboard in your computer, had an interface with a little lever, and you could pop the chip out and change chips, right? Or the idea of inside a desktop computer you could change the RAM, right? Well, they weren't doing any of that. It was all soldered in there. We found by adding 1.5 millimeters of width to the handset, the hand radio, which is about this big, they could modularize the whole thing and still have the frequency shielding they needed. So they modularized the system internally, completely decoupled it from the aesthetic shape. So suddenly the UI design team was thrilled, which by the way, we wanted them to all be one team, and last I heard they hadn't done that yet. UI design was still their own. I think they'd go faster if they were all together. But they were thrilled because now they could iterate on their own cycle and start using 3D printing if they wanted to and make new handheld shapes every day if they wanted. So it was modular. So they used Scrum for the design, and then Scrum for the production, and then object-oriented architecture for the part itself. And all of this was done using test-driven development, pairing, swarming, other XP good practices. The team launched on Monday, and they did hand a working prototype to a proxy customer on Friday. And that had never happened before. Thank you, Tate, for being able to let me show photos. So that's a use case. And again, we decided to give it a name, Extreme Manufacturing. Here's what we're trying now. This is an Arduino circuit board. I'm not sure if anyone in the room has used it or not.
I did.
Awesome. So quite a few people are familiar. So it's about the size of a credit card, and it's $24. And we use it to replace a piece of electronics that's $800 in traditional cars. So that's lean in a usual sense. It costs less. But here's how it's lean in a software sense. The thing we were using before to control all the automotive functions, not only was it expensive, but it used a proprietary programming language. So if we wanted someone to come in and make a change, they'd have to learn this new system. And there weren't good tools to work with it. Arduino, there's hundreds of thousands of people that know how to use it already. It uses a derivative of C. So when we want to make a change to our cruise control algorithm, we post it on our website and with our GitHub address. And someone somewhere in the world makes the change and uploads it to us, and we run it through our test harness, and if it passes, we put it in the car and we're done. We don't even have to pay anybody anymore. You guys are awesome. Thanks for the energy.
You are awesome.
Together, we are awesome. So there's the lean piece, and then our agility, we don't use it just in our delivery team. I mean, that was a great start, but we use it for the whole project. This is our business plan. It's a set of sticky notes on the wall. Here the Discovery Channel's filming us. So we said, well, what we were going to do at this stage in our business plan was build this thing and do these things, but the Discovery Channel's here. So we moved that part of executing on our business plan and wrote a new one that says, take the Discovery Channel for a ride. And then we put in another one that said, test the version 4 of the engine module and then test the Le Mans style car body. So we switched the business plan. That's our backlog, but that's also the key financial levers for the whole company. So if a game-changing technology comes around today, we'll move the sticky notes around, take a picture of it, email it to the team, and everybody knows, and we're done. We use Scrum, and in this picture, you can see all of the members of one Scrum team. This is the Hillsdale, Michigan team. And there's the Scrum Master on our right, Lisa Ford, the product owner on the left, Brian, and then 3 of the team members working together in a swarm. And what they're doing here is they're taking one carbon fiber car body off one car and putting it on another car. Because it's modular, you can swap them to test them in different scenarios. We use pairing and swarming. Here's 2 team members building one of our engines. This means we don't have to train people, and we're able to reduce documentation. We've eliminated most documentation. Because when someone joins the team, we don't put them through a training regimen. We just say, please start building a car for a customer, pair with someone who's done it before, and if it passes all tests, you win. And then we'll put someone new with you to pair next time. And then we use a tool called Carica for our workflow visualization. I am tool agnostic. I know and love a whole lot of tools. The thing that currently is amazing about Carica is we can embed YouTube videos in any of the cars. It uses Google Drive behind the scenes, so any Google document, including YouTube as a Google property, can be put in the cards, and we film every demo, and we try to make them less than a minute long. So it's, here's this is what works, this is what doesn't, here's the current state. And we have one of the people who bought our car get in the car and use it, and they give their reaction. When we post it right in the sticky note, and so the team members in 20 countries now can see that, whether they were there at that demo or not. And that's it. That's almost the entire communication we have across the company. Because anytime you have communication, you introduce slowdown, right? So you want high bandwidth, awesome, useful communication. And that's why I currently like Carica as a tool.
Wiki speed SGT01 pulling away from the stop sign outside of Hillsdale, Michigan. Driver Brian Ford, passenger Joe Justice, and this is Ron Pearson. Holy cow, they're just gone. What's that?
We found the team was way happier when they got to have fun with the project as often as they wanted. So every single Thursday is what we picked. We make sure that we put the cars together, however many are in process, and the team just gets to play with them. This is a really early version of the car. You saw that one didn't even have a body on it. This was right around the time of the X-Prize. But every Thursday, the team gets to play with the cars, and we found our velocity keeps going up when we do things like that. That also is the reason why we have beer on our snack shelf. For more information on any of this stuff, you can go to scruminc.com. There's a set of white papers, a webinar, and a blog that detail most of what I'm talking about. The Agile Lean Scrum and the Extreme Manufacturing component. There's actually an Extreme Manufacturing webinar there now that goes into more detail than we have time to today. So if any of it's useful or relevant to you, you can see it there, or you can send a link to coworkers if that's useful to them. Awesome. Team Wikispeed now has, there's more than 500 people that have signed the form. About 175 are active in 20 countries. The only reason we have a coherent product coming out is because of test-driven development and what we call continuous integration manufacturing, where we run a set of tests when they upload CAD to our Dropbox folder. It's exactly how it works in software. You do a check-in, it would run tests, you get a red light or green light, it might auto-deploy. Well, we do the same thing. The car has 3D drawings of each part that people make, but we don't count it as done until there's a working, tested physical prototype. That's what ensures it's manufacturable, or at least fabricatable, which is a little different. And we use the same process controls you would in software. We automate crash tests, we automate stress tests, we modify airflow and heat exchange tests. Those are all things you can simulate on a computer, just like you would do SQL injection and attack protection script or whatever. A project we're working on now is the Wikispeed Microhouse to help end involuntary homelessness. I love the idea of people going and living in the woods if they want to. That's cool, I think. But for people that wish they had a lockable front door or a clean bedroom or a clean bathroom, we thought we might try to solve that. That's a huge, audacious goal, but we thought, well, let's try, let's iterate. And the goal we said is let's make sure it costs less than $100 US. But it has a clean bedroom, a clean bathroom, and a lockable front door. Here's a mock-up of this hyper-insulated tube that's, you walk inside, and a human puts out about 200 watts of heat an hour. So if you hyper-insulate the structure enough, ventilation is your bottleneck, not heating. So you don't actually have to be on the grid. And then we're working on a UV and physical filtered water system for a shower and a bathroom that's built in. And anyway, that's the project that's in flight now, as we're trying to save the world. Thanks. There's even a close. Sorry, it's kind of anticlimactic now. That was amazing. I'm probably at time though, right? Or past it? It does mean we don't care. I'd like to invite folks to do some awesome when you can. The average member of Team Wikispeed spends 2 to 8 hours a week working on Wikispeed projects. They log into the backlog, the Carica, and they pull the next highest priority card that they're excited about or they have done before. Sometimes they have no idea about it, and they then email the team alias and say, I haven't done this, but I want to try it. Who can pair with me? And they pair with someone through Skype, or if they're in the same town, they meet. And they work on that backlog item. Join Team Wikispeed. Everybody in this room, join Team Wikispeed. At wikispeed.com, there's a tab that says Join the Team. You click there and you join. Please do. Sharpen your Agile skills by doing that, and let's make the world a better place. But even cooler than that, you don't need Team Wikispeed to use fast methods like Agile to make the world a better place. You're welcome to join it. And there's groups already in many countries in Europe, or the United States, or Asia. So come hang out and let's make the world awesome, even more awesome. But you don't have to join the team to do that. What I'd like to ask at least is, please consider taking 2 hours out of your week, a week, and use it to rapidly solve problems for social good. Try to make your neighborhood a little bit cooler, or your city, or maybe the whole world in a small amount of time. And about the time it would take you to catch up on a TV series you like, you might have a working version 1 of something that makes the world a little bit more awesome. And if everybody in the room did that, it would be so awesome. It would be like science giving a high five to Mother Nature in front of the Big Bang. Folks, thanks. After this, I do have a set of video clips and stuff to show 2 sprints of the Wikispeed shop. But probably people need to catch flights, and I'd like to respond to questions and start a conversation. Afterwards, if anybody doesn't have to fly, I don't have to fly till Sunday morning, which is great. So I won't leave the room until they make me leave. And we can even flip through 2 sprints if you want to see what that looks like. But first, let's see if there are questions. Hey, you said this, but I don't believe you. That's all fine. If there are questions, now's a great time. Yes, you're the first hand I saw in the striped shirt.
I wanted to ask, what is Wikispeed? Is it like a company? You want to make money, or
right.
Power? Or?
So in an hour, I'm only so good a presenter. I didn't cover all bases. I don't even think I told you we didn't win the X Prize. We tied for 10th place. So that's a commonly asked question, which meant we outlasted 100 other car companies around the world, like Tesla. it was huge, right? And from my garage at that time, really.
Yeah, but they make the Model S, come on.
Yeah, and it's a really nice car.
Really?
Although their time to iterate the next version is several years. They use traditional stamping. So it's cutting edge now, but they're married to the same lead time as everybody else. I hope they evolve past that. We'll see. I hope so. But your question. Oh yeah, but it was specific to what is WikiSpeed. WikiSpeed is a non-profit corporation that's a registered automotive manufacturing company to make prototypes. Then there is WikiSpeed Manufacturing that takes traditional investment. And their goal is to produce at least 60,000 WikiSpeed cars. So they're a traditional for-profit manufacturing. Yeah, they're for sale now. Now, just to let everybody know the size, this is small. We've sold 10 cars. Not 10,000, 10. So that's where this is. We're talking about this from an early stage. When I talk about these practices in high volume, that comes from the clients we work with, like Boeing or Lockheed Martin or John Deere, because we get to see them use it on big scales. In Team WikiSpeed, we're in 20 small shops.
How much does it cost?
25,000 US. In the US, that's about the same price as the least expensive Toyota Prius, to give it a comparison. So we're about the price of the base Prius, and we're about twice the fuel efficiency. We're totally prototypes. To make that explicit, none of our cars have roofs. They're all roadsters, like race cars. They're basically road legal, safe, ultra efficient race cars, because we think of them like beta projects.
Where can I order one?
Oh, our website. There's a button that says "Buy Now," and you can. How long does it take? We use a Kanban queue, and we're constantly optimizing. But right now, I'd say honestly, the lead time of number 11 in the queue would probably be like 6 months. Sorry. We're optimizing flow all the time. But yes, the trade-off is you become the product owner of your car, and you get weekly demos, and you can make changes and reprioritize the backlog. So WikiSpeed as a nonprofit, Team WikiSpeed, is open source, nonprofit, nobody's paid, and we produce the coolest things we can, like the micro house, like the ultra efficient car. We have backlog items now on helping deploy the rotavirus vaccine, because we were working on polio already, and it's now, we didn't do it, we helped, but it's now pretty much eliminated, mostly thanks to Rotary International. So we iterate on those, and it's open source for anyone to produce up to 10 cars a year. So someone could compete with us and sell up to 10. And that means even Team WikiSpeed is capped at 10 a year. And then WikiSpeed Manufacturing has the license to then be the mass distributor. And so that's the thing that can take investment. So they can produce, and their goal is to make 60,000 WikiSpeed cars. That's what they're missionized to do. So that's the business relationship. Does that even make sense? Oh, okay. Well, that's what we're trying. We'll see how that pans out. It's looking interesting right now.
So you still want to be a millionaire, but you want to make it
go
to another place?
I actually am one of the people that wants to go live in the woods. I'm almost allergic to money, but I want WikiSpeed to be able to prove itself as a social good concept that's also compatible with profit corporations, so that they know they don't have to be dicks and they can actually do awesome work. Tweet, Joe Justice says they don't all have to be dicks. Thanks.
And he must be right because it's called Justice.
And yes, that is my real name. That's a question I get asked sometimes. Were there any other questions? Oh, here's one right in the front. In the blue shirt.
Yeah, in fact, I have two questions.
Oh, gosh.
When you run a workshop, like in a conference where they build a car, who gets the car in the end?
Right. So I think everybody heard, but when we run a workshop, like in a conference, and we build a car, who gets the car? It depends. In Lockheed Martin's case, they rented the car that they built, and Team WikiSpeed got it back, and then we sold it, which is great. Thank you, Lockheed Martin. when another company that I can't name yet is building the car, they're buying it, and then their plan is to raffle it off for charity with their company's name on it. When we built the car at Agile 2012, Team Wikispeed kept that as a demonstrator. What did we do? We later sold that car too. When we built the car at Red River College, they kept it, and that's part of their curriculum now. They run those workshops as part of their project management class and in their College of Business. So they say, you need to know about Agile for hardware, and to do that, this is one of the things they do. And they run what's called an extreme manufacturing build party. and they do that as part of their, so they kept the car to keep running it. Did that answer your question, or did I miss it?
Yes.
And then you had a second one?
Yes, you said there were 5 rules: the safety shelf, the snack shelf, the visible tools, and the backlog of tests.
Mm-hmm.
What was the 5th? Actually, the 2nd.
Yeah, right. So, gosh, now I've got to think pretty hard. And I was like, thank God I don't have a picture of it because I don't remember it. So there's the safety shelf, there's the snack shelf, which we saw. So that's, yeah, well, but that's where I'm getting confused because in the shop, that's the second thing I touch in my shop in Seattle. My shop is the one closest to me. And then there's all the tools are organized visibly, like with like, in the fewest categories as possible. And then there's the Kanban board.
Maybe it's the materials.
No, it's not. And yeah, you know those moments when you're in front of a room and you go, I wish I remember this. Like I know that like the back of my hand. I don't remember it right now. No, today there's totally fine. You could go to wikispeed.com and it's all there. Like I wrote it, like I know about it. The webinar on Scrum Ring does go through it. And well, thanks for asking. And if I think of it before everybody leaves, I'll say it. Or if some of the, who here in the room is or has ever been a member of Team Wikispeed? 1, 2, 3, 4. I think there's one more. Well, look at those people and ask them questions too. And be like, did Joe tell the truth? Right? You can ask them, and maybe one of them remembers the 5th practice. So those folks too. Any other questions while we're together as a group? Yeah, right here in the front. You.
So I totally understand that this is an awesome way to get from 0 to 10 cars.
Yeah.
Now suppose you need to go from 10 to 10 million, not 60,000, 10 million, like Toyota or something. Would you say then that company would be like Toyota, or would it still be very different?
So 10 million is a larger count than I've seen. When we're working with some of the partners, we do see some large volumes planned, and thousands, tens of thousands, sometimes hundreds of thousands. 10 million, I haven't seen. Here's my guess. My guess is what would be different between a Toyota plant now, because I actually would have some commonalities. And what I'm talking about is the design team would be at the head of the line. They'd be part of the line. And so the person making the new version of the vehicle would be right there, and they'd practice deployment on, in my opinion, on their sprint cycle. So every week, whether it's a new version of the car or not, whether they have something different that's passed all tests or not, and there'd be test fixtures not at the end of the line, which Toyota has now. I've been lucky enough to see some of the plants. But they'd be during the line and at the beginning of the line in the R&D area. So the R&D area makes their prototypes, they pass their tests or they fail their tests, and when all tests are green light, it auto-deploys. And then it hits the line. It hits the rest of the line is the concept I'm trying to stress. R&D wouldn't be a business of people wearing different clothes in another building. They'd be part of the line. And that way the person who's doing the welding, instead of just doing the welding or the robot next to them and they're the welding robot operator, depending on the plant or the fixture they're working on, they'd be a T person where they might be deep in welding, they might be very skilled there, and they report up to the welding practice. But they're able to run the stress tests as well. They're able to also assemble the suspension, and they would have pairing throughout the line to decrease their bust factor and increase their agility. And they would have regular deployments. What that would mean is the machinery they use would probably start to change. They would probably no longer use stamped steel dies. Now, for manufacturing nerds in the room, there's a piece of tech out there that's not yet done, but it's an idea everybody wants. It's called dynamic molds. If you've ever seen the toy, it looks like it has a bunch of little pins, and you can put it on your hand, and it leaves the shape of your hand in little metal pins, or put it on your face, and it looks like you. The idea is if each of those is like a pixel, they slide up or down, and you put the aluminum on top or the carbon fiber, and they, like a printer, take the shape of the thing you want, and you have another one on top, and they press. It's not a complex idea, but nobody's got it working well yet. Once that works, we'll have all the cost reductions of traditional volume-based manufacturing tools with all the dynamic capability and lack of sunk costs of dynamic tooling. Right now, the best we have that's known and working happens to be what Team Wikispeed does use, is we take a piece of foam and machine it so it has the shape of what we want, and we lay carbon fiber on it and then pick it up and take it off. The machine to do that costs $2,700. The machine to stamp doors costs a little over $100 million. So although it takes longer to machine the foam and lay carbon on top, you can have 1,000 of them next to each other and still have saved significant money. So you scale out instead of scale up, like how Zynga, Facebook, or Twitter does with their infrastructure versus the idea of this one massive data center, which we've all seen doesn't scale, which also allows local manufacture and distributed manufacture. And then, gosh, I didn't show it. There's the idea of shipping container microfactories, where an ISO standard shipping container, those big metal boxes that go on trains or boats, you put raw material in one end, and Team Wikispeed is prototyping one of these now. We're not done. Some companies are already using them. You put raw material in one end, and cars come out the other end, and you scale out by adding these. And then if Rotterdam decides that all taxis need to get 100 miles per gallon, a group like Wikispeed would ship 12 of these over to Rotterdam, hire local employees and acquire local materials, and then when we're done with the delivery, we'd leave like 2 for maintenance, and the other 10 would go over to Berlin, where they've decided that all their postal vehicles need to get 100 miles per gallon, or 2.5 liters per 100 kilometers. That type of thing. That's my idea. We'll see what happens when it scales there. I wish I could say, I've seen it, and it's this. I can say this is what I think. And in scaling to hundreds of thousands of units, which lucky for me I am seeing, it looks pretty much like that. That's where it's going. That's my guess. So no, I do think it would be actually quite a bit different. Did that talk to your question? Or did I miss it?
I would have more about the other two last one.
Okay, well, if I'm really lucky, maybe I'll get a chance to continue the conversation on Twitter or over drinks. The next hand I saw, I think, was in the back corner of the room. Was there someone here that had a hand up earlier? Or maybe not. Is there anyone with a question? Wow, right in the front, in the plaid.
Can you tell us more about the micro house? What are you working on? How's that going?
Okay.
Who are you partnered with?
Yeah, the question was about the micro house. How's that going? What are you working on? Who are you partnered with? Currently, we don't have a partner. If that's interesting to somebody, gosh, we'd love to see what it would look like to help expedite. What we're working on now is when your finish materials, the exterior of a home or the interior, when the finished materials are your structural material, the thing that holds it together, it gets a lot cheaper. And you notice we have a price goal of $100, so that's very aggressive. So what we're trying now, and it works great currently, is we have these slabs of insulation foam. And they're thick enough and dense enough that you can walk on them and they don't deform, you can actually kick on them and they stay intact. And we take a bead of glue, epoxy, very strong glue, and put it down the side, and we take one of these foam panels and we stick it on, and we have one on the floor, and we put a line of glue, epoxy, and we take another one, we stick it down, and then we put 2 more lines of glue, and we put another one on top, and now you have this big rectangle, and then we have these doors that are hyper insulated, and all of a sudden you get in there and it gets hot just from standing in there. So we had to open the doors, and now we're doing mesh screens to keep out bugs, because even in the winter you need both doors open at least a little bit. It's so well insulated. It's comfortable down to 40 degrees below, and that's where Fahrenheit and Celsius converge, so pick your system. And so the current state is we have this hyper insulated box with doors on both sides, and you go in and you're cozy. And we have a lock on both doors. So you could have that feeling of safety if that's important to you. And that does cost right about $100. Then now we're working on the shower and the bathroom. And the very first increment of the bathroom is a little bucket. And you can take it So there's that step. But we're working on methods to connect it to infrastructure, if infrastructure is available, like sewage, and also solar composting. And then for the shower, we're working on solar water treatment, where there's a little solar panel which is very inexpensive and has no moving parts, so it's very durable. And it powers a UV lamp, which kills bacteria. And it collects rainwater, and the roof then, and we haven't done this yet, this is plans. The roof then collects rainwater, and then that's exposed whenever there's enough solar to power the UV light to cleanse it, and it goes through a mechanical filter as well that the user would have to clean. So basically just a porous rock, and it filters through. And on the other end you have drinking water. So they can open a little valve, and it's like a water dispenser, like a water cooler in your break room. The idea then is we would also have a heating element, and they'd have a shower in one area of the room. And then that would hit all three of the value statements, but we're not there. Right now we have clean bedroom, and by bedroom it means a warm box, but that's a start. I like to think of it as way better than just a tent. Yeah, it's not competing with, oh, thank you. It's not competing with a room at the Radisson. It's competing with a refrigerator box under a freeway, right? That's the idea. Yes. Yeah, so actually one of the first things we did is a solar panel with a USB out, so you can charge your phone or your tablet, and then use your phone or your tablet. If you have Wi-Fi, you're then a hotspot. So one of the hopes is that if someone wants to take a couple years off their day job and reconnect with life, and maybe they're not ready to go live in the woods, which I think is awesome, and maybe they say, I want the minimum, I want a clean bedroom, a clean bathroom, and a lockable front door, right? Maybe that's a start. Maybe even people that could afford something extravagant want to perform voluntary simplification. And I thought, well, if it's me, I'd also still want to charge my phone, because when I show up at work, I still want them to, I want to look normal, right? So I need a charged phone, I need to be shaved and showered. So let's make sure it's compatible with that. And that's the target so far. Even though it itself is this really small structure, when you climb out of it, we're hoping you look like every other member of society if you want to, which involves Wi-Fi. Are there any other questions? Great, I'm going to flip through the next two sprints. If you need to catch a plane, please go ahead and do it. I won't be offended. I'm thrilled we got to hang out as long as we did. For anybody who has time, if you want, there'll just be more data going across the screen and I'll be talking about it. But feel free to do something else. This will take, I think, 10 minutes. So if you need to go, that's cool. Or step outside and make a phone call or send an email. Won't offend me. For people who are really curious, here's what 2 sprints look like. Oh, Saket is telling me something. Drum roll. Saket
Who's got to leave actually quite soon now? Nobody. Me. You. Oh, sorry. Okay. So take care. Bye.
Ciao. Thank you. About 10 minutes. Is that? Yes. Okay, well, let's do it, right? How do you make an increment of a physical product in a single iteration? If it takes Chrysler 3 years to make a new transmission, how would you make a whole car in 7 days? Here's a safety iteration. So here's us iterating to improve safety. First, we pick the test we're going to target. So we're all test-driven development. In this case, it's the side impact test in the United States. So that's run by the NHTSA. We simulate the test. That's step 1. There's our chassis being struck by the side impact barrier. There's actually some cool, nerdy engineering around that, but I'll save that for a breakout session or people to email the team later. By the way, if you send an email to info@wikispeed.com, INFO, that goes to the whole team. So you won't just get Joe's opinion. So we've done the simulation. Then we test physically to see if our simulation was accurate. Crackle, crackle, crackle. This cost us $10,000 each time we run it. So we can't even afford to run this test every sprint. But I've just told you guys that we make new cars every sprint. Well, here's the thing. Our simulations are so accurate now, they match the physical test so well now, that they're accepted directly by the federal government. We're no longer required to create the things. We still run physical tests whenever we can afford it. We want to verify we still have correlation, but we don't actually have to. So we make sure we simulate every time we make a change. Then we iterate on that design. So this is the same sprint. We got that video from the crash test facility, and we posted it to the team. And that night, a father and a son pair came over to the shop and said, I think we can do even better. And they cut these big tubes of a softer grade of aluminum and bolted them on the side of the chassis. So that means those softer tubes would squish first before the chassis would squish. And they bolted them on that day, and the car was even better. So just by making the information available and keeping the shop unlocked, that's the 5th practice. And yes, it's practice number 1. Number 2 is the safety shelf. Number 3 is the snack shelf. Number 1 is the shop is always open. We don't want to have anything between someone who wants to do good and them doing good. Why would we say, no, it's after 5 o'clock? If you want to come in at midnight, save the world, go for it. So our shops have combination locks, or they have electric keypads, and anyone who signed the team member form, whether we really know them or not, we practice radical trust, they get the code. And to date, we haven't had anything stolen. We'll see. I mean, it will eventually happen. But to date, the most intense thing that ever happened is our backlog used to, and it wasn't for this reason, but it used to be open access to anyone on the internet. Someone finally renamed one of our user stories Poop. That's the most malicious activity that we've had from being radically open. But so the same sprint, this pair upgraded the safety module, and since it bolts right on, they're then able to send that out as a hot fix to any of the cars that are already on the road, because it's modular, right? So that's a safety iteration. That's 1 week going through. Here's an aesthetics iteration, trying to make the car more beautiful. First, we start with a 3D drawing, or CAD. This one also came from Rob Moorbacher. He sent that over through Windows SkyDrive. Now we use Dropbox across the team. And then we cut it out in foam using a computer-controlled machine, a CNC, computer numerically controlled. And that takes a day. So it takes a day to cut out that 3D drawing in foam. And that foam are the same slabs of foam that you put in walls. It's the same stuff we use in the micro house, actually the same foam. So we use our scrap from this and make housing prototypes, is how that project kicked off. We're like, we already do this, and it's hyper-insulative, and it's a waste product for us. So a day later, we have a life-size car to walk around. And then we lay carbon fiber on top, and that takes another day. So now we have this carbon fiber skin, and then we very carefully mix and pour epoxy on top, and we comb out all the wrinkles. It's like ironing a giant shirt. It takes all day. But it takes a day, and then we go out and we have dinner, and we come back and we have a car show. And then we go to the largest auto show in the world. And this was January 2011 in Detroit, Michigan. And they had 750,000 attendees and 5,000 members of the credentialed press, and I was terrified. I had no idea how the big three or the other automotive suppliers would react to this startup, right, that made their car 3 days before the show. And they put it on the main floor between Ford and Chevrolet. And so this was one iteration, right? This was the week of the auto show. We did a aesthetics iteration. And then we were filmed by the Discovery Channel. And we asked them for permission to use clips of their video in marketing. And they said, sure. So in that same iteration, we used their clips to launch a crowdfunding campaign to finance our next iteration. So the gentleman who asked about the company structure might have been curious. we don't worry about a 5-year financial plan. I mean, we don't know anyway. We're an agile business, so we don't even pretend to know. What we do is we try to make sure we have enough money in the bank to finance the next week. 1 week of run rate. And incidentally, for teams in 20 countries, that's $2,000. That's almost free. So we're extremely lean. We have no paid staff, right? That's all materials and overhead, like renting commercial space and power and that kind of thing, and parts and supplies. And then we sell cars, and that covers a lot of it. But all of that $2,000 a month is covered by people who PayPal us $10 a month. They subscribe to send us $10 a month because they think what we do is cool. It's because of this is the tie-in. We don't try to finance ourselves for 5 years. We say, let's make sure we have enough money in the next week, which means whatever we demo this week has to be awesome enough that people who watch it are going to want to send us $10. And that's the pressure. So the world is kind of our product owner. The internet is our product owner. And we do have an internal product owner. Sometimes it's me, but not always. We change based on what we're building that sprint. Whoever knows the most about it is the product owner. But the internet, I guess, is our stakeholder, our funder. And whatever we demo has to be awesome enough that it says, that makes people have to say, I've got to send them $10 a month. And that runs the whole company. And that is 2 Wikispeed iterations. Folks, thank you very much. I'm all done, and I'll mingle with you afterwards if you'd like. Thanks, guys, very much. I believe the conference was going to close. If you'd like to announce the raffle winner of the Wikispeed car, I'm kidding. I wish. We talked about building a car right here. Yeah, it's me.
The raffle next week.
Yeah, we talked about building a car right here in one of the sessions, but we weren't able to get a sponsor to ship the materials in. There is a Team Wikispeed team in Nuremberg, Germany, by the Nürburgring. And there is a team in Emmentaler, Switzerland. So they could build parts and send them here, but some of the parts would still need to come from countries even further away, and we didn't have a sponsor to cover part shipping. But maybe next time.